I'm Alyssa Abo, and I'm the VP of Clinical Innovation at DeepSight. And I'm here to talk to you about our smart sensor technology and how we are transforming interventional procedures. I have no disclosures. So by background, I'm a physician and an engineer, and that really gave me the opportunity to innovate over the last 20 years. Throughout my career, which was really at the intersection of academics and industry, I was focused on medical devices and imaging, specifically ultrasound. The theme throughout my career was how to leverage technology to improve healthcare. And I'm thrilled to be a part of the team at DeepSight, and we are doing exactly that. So technology is quite the buzzword these days, but I feel like it's been the buzzword for quite some time. And rightfully so. Technology affects us in our professional lives and our personal lives, and it basically impacts how we practice medicine. But it's not just technology in one point in time. It's the evolution of technology and how technology has changed the way we practice medicine and how we care for our patients. So here's an example. If we think about the evolution of medical procedures, I can't help but think about my dad. My dad's a surgeon who started his training in the 1970s, and at first he was a freehand surgeon. Over the course of his career, he had to learn laparoscopic surgery and was one of the leading surgeons in our area. Fast forward to a few years ago, it's actually remarkable to think that robotic surgery saved his life. When I think about my own career in ultrasound, I remember in the emergency department pushing around an ultrasound machine that was the size of a refrigerator, and it would only work if we plugged it in. Now I can actually take a handheld device and obtain an ultrasound image in the palm of my hand. We can debate the image quality later. So then the question really remains, when you look at this image of the liver, despite using an echogenic needle, it's quite difficult to see where the needle tip is. So I can't really, with confidence, tell you exactly where that needle tip is. Now I know, some of you might be thinking it's probably because she's an ER doc and not an IR doc, and there might be some truth to that. But I actually think it's something more. Over the last several hundred years, there really hasn't been much evolution when it comes to medical instruments. Think about it. A needle from the 1800s, it really looks like the needles that we use today. And despite all of that, the procedures that we all do are more complex. There are always critical structures nearby. And I think regardless of our specialty, unfortunately, there's a shortage of skilled practitioners. But when it comes to ultrasound-guided procedures, it's really important that we're able to see the needle for visibility. It's really important that we're able to track that needle or instrument. And without that, I feel that it puts ultrasound as an imaging modality at a disadvantage. So we need to have an evolution of instruments. And we at DeepSight are really committed to this, but not only just to be a part of this evolution, but really to revolutionize the way we use medical instruments. And we're doing that by placing a sensor in instruments. And we can put this sensor in any instrument. Needles, wires, catheter, the sky is the limit. And our goal is really to use this sensor technology so that we can deliver clarity, precision, and confidence so that ultrasound-guided procedures are really back at the advantage where I believe they should be. So how are we doing this? We have an entire NeedleView platform, which really is a combination of software, hardware, and sensor technology. And this allows for a new category of what we call smart instruments. These smart instruments allow for localization, tracking, and on-point imaging. So let's take a look. Imagine that you have a needle in the liver, and you get this ultrasound image on your traditional ultrasound machine. The green dot is showing you where the sensor is located, which is in the tip of the instrument. But what if I told you that the sensor is optoacoustic, and we use light to detect sound, and from the tip of the instrument, we can actually generate an ultrasound image. So this image that I just put up, the green dot at the top, is actually the sensor. And what you're seeing is the image from inside the liver. So I know people are curious about that, so let's take a closer look. Here we're sticking a needle in the phantom. So on one side where it says needle localization, you can see the green dot at the end coming through. Again, on the other side where it says from the instrument tip, this is our on-point image. And this is an industry first, that we're able to look at the ultrasound from within the organ. So at the end of the day, really, what's the advantage of a sensor? Our sensors are quite small, they're 50 microns, they're non-electrical, and we can put them in any instrument. Because of that, we can also look at tracking. We can look at tracking in and out of plane. Our sensor can be at any angle and at any depth. The sensor self-calibrates and can detect changes in temperature and pressure, and we can use it in any environment. So the goal really of all this is that we create a situation where the procedures are safer, they take less time, they lead to better outcomes, we decrease radiation for everybody involved, and there's a lower cost point. We are very fortunate to have partners at the NIH to help us generate evidence. We take clinical evidence very seriously, and we realize how significant it is. There are 2 abstracts that are here at CIRSE, which you can see in the poster area or on your phones or computers. The first abstract's around accuracy and the accuracy of the sensor, and the second abstract is how the sensor functions in different environments to include ablation. So please take a look at both of those. So if I end with the image where we started, now you can see with precision the green circle that's coming through, that's the sensor. And if you notice, hey, there's a color change, you are correct, and that is showing you when the needle here is out of plane. We truly hope that you will join us on making the invisible visible. And we thank you so much for your time, and we hope that you will swing by our booth, see the technology, and hear from my colleagues who are interventional radiologists on how they believe the technology will impact their clinical careers. Thank you so much.